All right. If anyone needs a handout, there's some extra over here. I'm not sure if we're still waiting for people or if that's like all the survivors that are left. But you have a test tomorrow, right? Yeah. All right. Is it calc or what is it? Oh, okay. Well, in that case, the hard part is over. So, all right. What is it? No big deal. Okay. All right. All right. Like we'll do some easy stuff and some hard stuff today. And we'll start, I'm sorry to say, with the hard stuff, which is exercise C. How many people have done exercise C? All right. Okay. So I feel like, okay, I feel like you've probably worked hard enough. So I think I will do exercise C for you. And then there you are. And then we'll move on to some more examples, which I will ask you to try. And then we'll maybe start something new and easy. So, okay. So this is exercise C. So basically, again, kind of the way to approach it with the memory table approach, we'll see a different approach after this, is to just go line by line and say which rule applies. So line 1. First of all, this is a new list on the right-hand side. The new list needs to go into memory. So that means that, I'll just place 5, 6, 7 somewhere. So for L to be defined, we first need to define the sublist, the 5, 6. So I'll just put it somewhere in memory. So this would be at 1000 at and thank you to the person who suggested the quote at 1010. Okay, it needs to be a different one. Oh, okay. Okay, we'll live with this. Next time it's gonna work. Okay, so we stored this list 5, 6. It doesn't have a name, it just needs to be in memory. So now we define the actual list L. So that would be at 1030 at 1020. It did work the last time I tried. And maybe it's the square brackets. So what's going on? So what's going on here? So this list L, it has 2 elements. The first element is the 5, 6, and the second element is the 7. So 2 elements means that this is a list with 2 elements. It's just that the first element is itself a list. So what we did is we first placed 5, 6 in memory because it has to be somewhere in memory in the same way that the 5, 6, 7 need to be in memory. And then we also put in the 7, and now we have the list L. So now that the right-hand side is fully defined, we can put it here and say that L, and this is now going to work, is at 1040. Make sense? So, okay, so we are done with that. Line 2. So same principle. So we are defining a new list. So square brackets on the right-hand side means that it's got to be a new list. Its element is L at 0. So in the same way, then when you say 7 here, what turns out to be the case is like you just write 10, so you just write 1020 here, so wherever 7 is stored. When you say L at 0 here, you just copy the address of L at 0. So L1 is going to be a new list. And then what's L at 0? It's 1030. So this is going to be 1030. So we just took this and we copied it over here. So this does look difficult. So kind of when you're thinking of, like, for one thing, like that's the only thing that's ever going on. So you always do it like this. But the way to think about it is, am I creating a new thing? If I'm creating a new thing, I need to put something into the memory table, or am I not creating a new thing? The only way to create a new thing is to put, a new list. So something in square brackets, that would be a new list, or to put a literal, so something like a string or a number. So neither of those things are going on when you say L at 0. L at 0 is just whatever L at 0 is, in the same way that 7 is whatever 7 is. If you have outer square brackets, or you have a literal, so literal means like data, like 7 or like the string high, that needs to go in the memory table. Neither of those things happened. So, okay, so we've created L at 1. And now we can say L1 is at 1050. All right. We are now saying L1 at 0 at 1 is something new. So first of all, on the right-hand side, are we creating a new thing? Well, if it were a new number, yeah, but 7 is already in memory. And now what we got to do is we just got to copy the 1020 to the appropriate place. That's the only thing that ever happens when you say put the right-hand side in the left-hand side. Whatever is the address of the right-hand side gets copied to the appropriate place. What's the appropriate place? So L1 is 1050. L1 at 0 is this guy. L1 at 0 at 1 is this guy. So we're copying the 7 to 1020. The 1020 to here. So that was a mouthful. I recognize that. And I wasn't thinking about it that way. The way I was thinking about it is, okay, I know what L1 is. L1 is this guy. L1 at 0 at 1 is whatever is the element L1 at 0 at 1. There's only one place where it could be. That place is this. So I just copied it here. So let's switch for a second to Python Tutor. And that might make things easier. So here's the way it visualizes this. So we created, sorry. Yeah, this is good. So we created the list L, and the list L has two elements. So it has the 7 and sorry, I need the arrows. So we have the list L, and the list L has two elements. One of them is the 5, 6. So L at 0 is the 5, 6. And the other one is the 7. Now we creating L1. And L1 is the list whose first element is L at 0, whose first element is 5, 6. So what you see here is L1 has L1 at 0, and L1 at 0 is this list 5, 6. When I think about it, I usually just say, okay, like there's just the one list 5, 6 here. So when I say L1 at 0 at 1 equals 7, I'm modifying this guy. You can also think about it with the arrows. So with the arrows, L1 at 0 is this list in the same way that L at 0 is this guy. So when you're saying L1 at 0 at 1 equals 7, that's the same as saying L at 0 at 1 equals 7. So that means that you're modifying this 6 or this 6 to 7. All right. So let's go back to the memory table. So here we did the same thing. So let's now say we are at line 4. So we're saying L1 at 0 is this new thing. So here on the right-hand side, there is a new list, outer square brackets. That means it's got to go in the memory table. So we'll put it over here, and that's a new list. That's equal 7. So this is at 1020. And now we got to say, okay, L1 at 0. So this is this new list. We're copying the address. It's always the case that when you say put the right-hand side and the left-hand side, you're copying the address somewhere. So in this case, we're copying this to over here. And now we are printing L and we're printing L1. So what's L? So L is 1040. 1040 is 1030, 1020. 1030 is 1020. So this is 5, 7. And this is 7. So this means that this is 5, 7, 7. So the way I did it is I just read it off the memory table. Let's go to Python Tutor and see what's going on here. So here we are creating this. We are creating the 7. So we now have this, and now we're printing L. So L at 0 is 7, and L at 1. Sorry, did I get confused? Yeah. So sorry. So L at 0 is 5, 7, and L at 1 is 7. So that's what's going to get printed. And then L1 at 0 is the list that contains 7. So that's going to be a list that contains 7. So one thing to acknowledge, so like exercise C is obviously difficult. And there's 2 ways of thinking about this. So one is just grind through the rules. There's just 3 of them. If you think about it, it's not ambiguous what's going on, but it's hard. The other way is to try to do it with the arrows. I'll do it again now with the arrows. I think about it with the arrows, but I'm like so used to it that I do it in my head. I think initially doing it with the arrows is a little bit difficult because the rules are kind of like there's not like a lack of ambiguity the same way that you get with the tables, even though the rules with the tables are kind of difficult to apply, but they are at least unambiguous. If you like, there's no choices there. So, okay. So let's do it again with the arrows. So we are creating L. and it has L at 0, and L at 0 is the list 5, 6, and L at 1 is 7. Okay. Now we're saying L1 is a new list, and the first element of the new list is L at 0, because we're not copying L at 0. So that means that L1, it's going to be a separate list, but its first element is going to be the same list 5, 6. So the way I personally think about it, and different people just do different things. The way I personally think about it is, hey, I never copied the list 5, 6 anywhere. So there's only one list that says 5, 6. If I go and modify it, it's going to get modified however I access it. The way to think about it with the arrows is L at 0 is this list 5, 6. So this is this list 5, 6. And L1 at 0 is also this list 5, 6. So now when we go and modify the contents of L101, what we're doing is we're modifying this guy. Whether we access it, we are L, or whether we access it, we are L1 doesn't matter because it's the same location. So at this point, L at 0 at 1 is 7. And L1 at 0 at 1 is also 7 because there's just one list that is now 5, 7. Here, something different is going on. So we are saying L1 at 0 used to be something, and now it's going to be something else. So we're going and we're modifying the contents of L1. We're modifying this guy to be something else. So if we're modifying this guy to be something else, the 5, 7 stays the same. It's just that L1 at 0 now is going to be something new. Okay, so what happens is it used to be that L1 at 0 was the list 5, 7. Now L1 at 0 is this new list that contains 7. So the difference is here we went and we modified this guy. And that means that we could access it via L and L1 together because both of them are able to access the 7. Here we are saying L1 at 0 used to be this list. Now I want it to be a different list. So that's why this affects L and this does not affect L. And again, here we're going to print 577. And here we're going to print this guy. Right? So, okay, so this one is like obviously kind of a bit of a challenge, but I think it's like a good exercise. Do people have questions? All right. Okay, let's do something slightly easier, except now you have to do it. So we're going to question 5 from 2021. Oh, sorry. There's like one more thing that's super easy. There's a quiz. So if you did the quiz last, so I just kept the quiz from yesterday because I kind of didn't announce it, so that's still open. But if you didn't do the quiz yesterday, now is the time. Right. I'll let you think about question 1 for a second.
said this assignment was blocked a minute ago.
Hey, what?
Yo, it's quiz 5, right?
No, it's quiz 6. All right. All right. The correct answer to question 1 is ESC180. What's question 2? Who says A? Says B? Says C? Who says D? All right, nobody's independent minded here. Okay, anyway. So okay, yeah, you're correct. So C is correct. So nothing interesting is going on here, right? So we have exam is civ, exam 2 is phys, and then we say exam 2 is exam. So at this point, exam 2 is civ. So now it's civ. And now we say exam 2 is ESC. So it becomes civ ESC, right? So there's nothing going on here. One way to think about it is the only things that's where you have two things locked in together is when you go and modify the contents of something. So essentially, if you have square brackets on the left-hand side, then something might be going on. Square brackets on the left-hand side is the only way that we ever modify the contents of something. Okay, so anything where on the left-hand side, you just have a variable, that just means that you're copying stuff to the variable table. Copying stuff to the variable table, nothing weird is going. Okay. All right, so let's now go here and do 5A. Okay, I accidentally gave someone edit access to this because. Okay, do not edit it. Okay, I don't know how. Okay, I trust that you pressed the button by accident. Okay. All right, we're still working on this. All right, I'll give you a minute. All right, so let's first do it in Python tutor to hopefully get a bit of an intuition. And then we'll also do it with the tables. All right, wait, what? Oh, okay, fair enough. The answer, yeah, okay. So the answer here was that this is indeed just an error. And the reason this is an error is that L is a local variable over here. With that said, there is something that's printed before, so we'll do that. So, okay. So what happens here is we define the list L1. So that's going to be 4, 5, 6. So now we have the list L1 and it contains 4, 5, 6. So what we do here is we send L1 to L. So in the memory table, that means that L1 and L refer to the same address. You can informally think about this as L and L1 being aliases at first, because we are essentially saying local L equals L1. And what you'll see in Python Cheater is that that is what happens initially. So the L inside of F and the global L1 both just refer to the list 4, 5, 6. But what's going to happen now is the right-hand side is create a new list. And we're saying the local L is now going to be something new. So now L, the local L, is about to now refer to something new. So this is the extremely usual thing that we saw before, where if you change a local variable, it doesn't affect anything outside the function, right? Because we're just saying the local L is now something new. Over here, we're saying change L at 0 to 5. So L at 0, this L at 0 is going to become 5. That's the local L. It doesn't matter outside the function because we changed L to not be an alias of L1. So inside the function, however, we just said that L at 0 is 5. So of course, it's going to print 5. So 5 gets printed. So now here we're saying print L at 0. L doesn't even exist outside the function. So that's going to produce the error. So that's because L was a local variable. As you see there, doesn't even exist. So you get L is not defined as the output. Yeah.
I want to mention if does our error or we write the first thing.
So it depends on it depends on the instructions. Here the instructions were kind of interpretable as you get to just write error if it eventually produces an error. I could also ask you to say what the output is, and then if there is an error at some point, say that there is an error at some point. So if those were the instructions, you would have to say 5 and then error. Well, I mean, it's kind of like we did grade it as if you just wrote an error, then that's okay in this case because it kind of implies that here. But yeah, I'll clarify it for next time where it does say like if the error is produced eventually, you have to say what the output is. Okay. Oh, sorry. I did say you write down the output. Okay. I did fix it at that point. Okay. Yeah. Never mind. It wasn't fixed at some point and because of your questions. Yeah. Okay. Yeah. So you have to say 5 in error. Yeah. Okay. There was like a midterm where that was an issue, but apparently not this one. Sorry. Yeah. Thank you. Okay. All right. So questions about this? Yeah. That is what it means. Yeah, it means no part marks just because it's like essentially like if it were that you could just that you would get part marks for getting some things right, then you could like automatically get 50% by just like looking at what the numbers there are and just like putting in random stuff because like you have a 50-50 guess rate. So yeah, it just doesn't make sense to do it. Yeah. There was other questions? But anyway, like this was 2021, so it doesn't mean that like it's gonna be the same, but it will be the same because like the other way just doesn't make sense. Yeah.
You would expect us to know the names of the error.
No, so I do not expect you to know the names of the errors. Okay. I might, so I can ask you like not by name, but I can ask you to explain why there is an error, but we would accept any formulation. Right? So like you could say, well, like this is an error because L is not defined, or you could say it's an error because L is a local variable that goes away. I guess those are the two options that I can think of, but like any reasonable explanation that gets into the reason why would be acceptable. On this particular midterm, we did not ask for that. All right. Yeah, other questions? Okay, let's do it the memory table way. All right. So we need 1, 2, 3. And we need 4, 5, 6. So, and we need some more space here. Okay. So L1 is 4, 5, 6. So that means that it's at 1030, at 1040, at 1050. And now that it's defined, we have the global variable L1, and it's going to refer to 1060. We are now saying f of L1. So it's as if we're saying the local L is equal to L1. So that means that we have an L and we copy 1060 over here. So always like if it's as if L is equal to L1, that means that we do not modify the contents of anything in the memory table, just copying an address. We are now saying L is 1 to 3. So on the right-hand side, we are creating a new list, outer square brackets. So that means that we have outer square brackets here. Like so. And now this used to be 1060 and now it's 1070. So that's the same picture as what we have here. Where at this point, L and L1 are the same list, but now L is going to be a new list. So the picture here is that this used to be 1060 and this used to be 1060. So L and L1 used to be the same list, but now L is this new list that we just created and put in 1070. All right. Now we are saying L at 0 is equal to 5. L is this guy, L at 0 is this guy, and now it's going to be 5, so that's going to be 1040. And when we print L at 0, that is going to be 5. Once we finish with the function, the local variable table just goes away. And that means that when we try to print L at 0, there is no global L at 0, so that would be the error. Make sense? Yeah. So no, you don't. So the question was like, what do you need to put F in the variable table? And the answer is like, I generally don't, just because there is like lots of other junk in the memory in the variable table as well. So like there is like underscore underscore name underscore underscore and stuff like that. So like if it were that I would be modifying F to something else, then sure. But given that I'm not modifying F to anything, like there's no point. So just for fun, like you could modify F, at which point it would make sense, right? So you could say, whatever, like F of L1, and then like F is equal to 1, 2, 3. And then like print F at 0 or something, right? So that would print 1 because like F used to be the function and now it's this guy. But that's like not the usual thing that you do. All right. Does this make sense to everyone? So we had this example where like technically F is a variable like any other variable. Like it used to be the function F, now you can make it be the list 1, 2, 3 if you want. So, okay. All right. So questions about any of this? All right. So let me do some easy stuff for the last 10 minutes. I think we'll do like one more example maybe on Friday once you're done with the midterms and stuff. So I just want to do dictionaries. So this is hopefully, I mean, there is like complicated stuff, but I'm not going to do it today. So this is just introducing this. This is an example from an old midterm. So the midterms are usually like Halloween themed, so that's why. So the example that we had in class this year with this kind of thing is usernames and passwords. But to just introduce you to this example, so like we're storing like the favorite aspect of Halloween for each kid. And what we're saying is Bob's favorite thing about Halloween is candy, and then Dorothy's favorite thing is costumes, and so on. And then Alice's is midterms. And the way we access this data Okay, this is like different order, but okay, whatever. So like something like this, right? And then like if we want to know Bob's favorite thing is, like names at 0 corresponds to faves at 0. So like Bob's favorite thing about Halloween is matrices, right? So, okay. So that is actually an inconvenient thing, right? Because here I'm relying on me being careful about making sure that those things align, making sure that the lists have the same length, or else like nothing makes sense, and so on. So the other thing is that it's possible, but not super easy to look up, okay, like for Alice, what is the favorite aspect of Halloween? So you have to find the location of Alice. And then once you find the location of Alice, you go to faves at that location. So it's possible we did it with usernames and passwords, but it's slightly complicated and it's also slow. So we haven't talked about the speed aspect, and dictionaries are faster, but why and how we'll have to wait until 190, but dictionaries are faster. So the way to do it with dictionaries is you can define a dictionary like this. So what you do is you say candy corresponds to Bob, and then costumes corresponds to Dorothy, and then midterms corresponds to Alice. And the syntax is it's in curly braces, and candy corresponds to Bob. You use a column for that. In order to access Alice's favorite thing, you do faves at Alice. So the terminology is that Bob and Dorothy and Alice are called keys, and then the corresponding things are called values. So this is just terminology. So in a way, this is just a generalization of how lists work, right? So you could, in fact, have a list like this, where you say, this is Bob, and this is Alice, and this is Dorothy. So if you define this, you can use it as if it were a list, at least for accessing, right? So this at 0 would be Bob, and this is 1 is Alice, and this at 2 is Dorothy. So that works the same, except with dictionaries, the keys can be anything. So technically anything that's not mutable. So not lists, but like any string or any string or any integer and so on. All right, so that's more convenient in that way. Does that make sense? So for example, like you could also say here, like you're not constrained. You can say like minus whatever is Mike. That's fine. And that's just because like those don't correspond to anything. I need to copy it now. And in fact, you can have like Arthur is your grade in linear algebra, which is what? 78. So okay. You wish. So okay. I'm just kidding. So this is like not the usual thing that you would want to do, right? But you can. The keys can be anything, they can be mixed. Yeah. Sorry, can you speak up? So the question was, can you have multiple values? So that's a great question. So you can have so first of all, several things that you could have meant. So you could have meant like, can I have something like this? And the answer is yes. So the value can be a list. The other way to interpret this is, can you have multiple thing? I don't actually know the name of the other ESC180 instructor, so we'll do Rob. And can Rob give the same value? Yes. Okay, so you can have you can have different keys corresponding to the same value, or values that are equal rather. What you cannot have is you cannot basically have a key corresponding to two things at the same time. So if this dictionary at Arthur is this, you cannot say, oh, it's also something else. It's like, it has to be something. So you can write it, so it won't produce an error. But you shouldn't do it. So the outcome here would just be that this is 1000. So like the last thing is what it's going to be. But obviously that's confusing. You shouldn't do it. And in a way, the better design for Python would have been to just disallow this completely, because this is clearly a typo. All right. Okay. So here is kind of the more organized way of thinking about it. So you can access it like this. So if you modify grades at CSC, then it was modified. So it was like 85, now it's 84. You can add stuff. So unlike with dictionaries where you can only modify existing entries, you can just say grades at math is now 87. That is fine. So now grades is going to be like this. So just to emphasize the point, you cannot do this with lists. So you cannot say L at 100 is something if 100 was not an existing entry in the list. I think we are okay. Good luck tomorrow. I will see you in the lab once you're completely relaxed and looking forward to reading. See ya.